Uh, Hello everyone, I'm Yong Chun, Assistant Professor of Electrical Engineering at the University of Hawaii in Manoa. Today I'm going to preview the Electrical Engineering program offered by the University of Hawaii at Manoa, especially with a special focus on the data science. I hope that this preview presentation help you to better understand the EE program and its data science program. Okay, right. So let's first take a look at the electrical engineering program at the University of Hawaii and Manoa, in short UHM. Okay, right. So the UHM EE has a worldwide research reputation by the development of this AlohaNet. So AlohaNet is the first wireless communication network, and that was originally invented to connect the computers in the different Hawaii islands. So UHM EE had many researchers working on this AlohaNet and its variants, and those include Dr. Abramson, who was inventor of this AlohaNet, and some other faculty members. Okay, so this AlohaNet eventually became a foundations for developing a Wi-Fi, Ethernet, and some satellite communications that we are using widely these days. Okay. So next, let's take a look at the electrical engineering. What is electrical engineering? So first of all, let's take a look at what engineers do. Right? So engineers make the world a better place. We engineers now turn a fuzzy idea into something real, and also use the math and science to solve the problems and create the new products and services. So as in electrical engineering especially, you'll work at the heart of the most rapidly developing technology that the humankind has ever seen. Right? So especially the EE department at the UHM now offers both electrical engineering, in short EE, and the computer engineering, in short CE&G programs. Right? So electrical engineering especially gives a broad overview of specialties, including data/information technology, wireless communication, control, circuits, solid-state devices, nanotechnology, electromagnetic, optics, computers, power and energy, robotics, biomedical engineering, and so more. And this computer engineering now focuses more deeply on the computer hardware and software and embedded systems. Okay. Then why this electrical engineering and computer engineering? So electrical engineers first control things, sense things, power things, design and build electronic devices, process data/signals, design computers, connect things and people, and lots more. Especially this electrical engineering allows a student to move into virtually any area, because this EE is one of the broadest of all engineering degrees. Okay? So this electrical engineering especially is among the top requested majors by the potential employers due to its versatility. Okay? And also it can provide the fundamentals for virtually any job in engineering or technology management, and is the pathway to many exciting careers throughout your life. How about the computer engineering? Right? So the computer engineering now gives you the deeper understanding about the hardware and software that now can run the world, and giving you the broad experience with component systems and programs. Especially the need for these technological advance never slows. So the demand for these computer engineering majors is strong across a number of the fields. Okay. Then let's take a look at some video clips that why the current UHM EE student chose this electrical engineering and computer engineering.
Hi, my name is Paula Peñolar. I am currently a sophomore here in UH Manila studying electrical engineering. I chose electrical engineering because it gave a good base for like engineering in general, and it gave a lot of opportunities about what you're gonna do and what it's all about.
Hi, my name is Jared Al. I'm a sophomore in computer engineering, and I graduated from Mililani High School right here on Oahu. So coming in as a freshman, when I was deciding what major to choose, I was kind of stuck between computer engineering, computer science, and management information systems, because those were the three big computer majors offered here at Manoa. After going to a number of information sessions and talking to several advisors, I decided on computer engineering because the core concept of engineering really appealed to me, because engineering at its base is solving problems. So being able to solve everyday problems by programming or working with circuits was a really exciting concept for me, versus computer science where it's more software oriented. Computer engineering is more encompassing. And also Manoa, the engineering program offers a lot of opportunities with the sophomore, senior, and junior projects, where you can work with a professor who's doing something that you're interested in, and you can do different things. So for example, in my sophomore year, I did the Arduino and app development project with Professor Sasaki, and next semester I'll be working with Professor Dong on his drone project. So there's a lot of opportunities here, and the engineering program is really robust.
All right, so that's it. And in the next several slides, I want to introduce some programs that the UHMEE provides. First, let's take a look at some undergraduate programs. So UHMEE now offer these BS degrees in both in EE and computer engineering. So both are accredited by this ABET system. Especially this ABET accreditation assures that EE program at the UHM now meets the quality standards of the profession. Okay, and we require you to take the following electrical engineering / computer engineering courses. Now those include computer software and hardware, analog circuits, signals and system, electrophysics, and some projects. Okay, and if you finish taking these required courses, then you might be interested in more advanced the courses, and you can choose certain tracks that you're interested in. And we offer the following technical tracks. Those include systems, aka data and information sciences, electrophysics, and the computer engineering. And also we provide these alternative tracks, which is biomedical concentration and the energy concentration. So especially this data and information science track now offers certain courses like communication control, data processing, and machine learning. And this electrophysics track now offers you certain courses like the circuits, devices, and sensors, and microelectronics. And this computer engineering track is jointly offered with these ICS people. Okay, and we also offer these project courses. These project courses now provide the long-term, in-depth, and the project-based learning to students, and it is designed for preparing the EE students for their future careers. And some examples of these project topics now include artificial intelligence-based tooth disease identification in the dental grafts, data discovery in big data, microrobotics, and the liquid metal electronics. As you can see, UHMEE offers some fundamental tracks as listed here, but at the same time, it provides significant hands-on experience via multiple lab sessions and the research experience by these project courses. Okay. So how about the grad programs at the UHMEE? So we offer this MS and the PhD degree in the EE. So some students may actually ask why we need to pursue these MS and PhD degrees. It's because it now offers the rigorous academic program, and this essentially makes you a sought-after candidate in this job market. And especially if you choose to write this thesis before you graduate, for example, if you choose to pursue a PhD and MS degree with the Plan A, then you now can work alongside with world-class faculty and researchers at the UHMEE, right? And so UHMEE now offers the following research tracks. The first, data and information science. Second, electrophysics. Third, computer engineering. And the last, biomedical engineering. So this data science information science track now provides some in-depth courses and also research experiences in data science, machine learning, and artificial intelligence, image processing and computer vision, communication and information theory, and network science. This electrophysics now provides the in-depth courses and research experiences in the circuits, devices, nanotechnology, electromagnetics, and energy. Computer engineering track now helps you to become a specialist in cybersecurity, privacy, Internet of Things. And this biomedical engineering track now offers you an opportunity doing a research in biomedical sensors and medical imaging. UHMEE also offers this combined bachelor's and master's degree, in short BAM degree. This is designed for high-performing UHMEE undergraduate students who want to commit to this MS program early by taking grad-level classes in their senior year. So it has two benefits. So this BAM degree now can help you to reduce the overall amount of time spent on the receiving both BS and MS degrees. So conventionally, to receive these both degrees, it takes about 6 years. But if you pursue this BAM degree, then you now can reduce this time up to the 5 years. Okay, and also this BAM can reduce the total cost of education. You now can take some graduate courses only with undergraduate tuitions. Okay. So in the next few slides, I'm going to introduce these data science programs offered in the University of Hawaii, Manoa electrical engineering program. So let's first introduce, I'm going to first introduce what is this data science. Basically, we are living in the data world. Wherever you go, you end up meeting this data. So data can be big data, unstructured data, and there's some mixed data, and whatever the data, you name it. Okay? And data science is a blend of multiple disciplines. For example, machine learning and artificial intelligence, statistics and mathematics, and this data analysis that now includes data collection, processing, and modeling. And essentially, once you learn these data science skills, then you can apply to the many data. You can apply to the data in the many applications. Such application can include some stock trend, or it can be some science, some autonomous vehicles, some medicine, some drug discovery, and it can be even applied to the text or the music or some cell phone devices as well. Now, why we choose this data science? So it's because the job market wants the people who has these data science specialties. So the Glassdoor ranked the data science as the #1 best job in America in 2009 for the 4th year in a row. Okay. And also, this LinkedIn listed the multiple data science related skills as the most in demand by companies in 2018. Okay. So this UHMEE has now 5 core data science faculty members, and this faculty member is among the 9 of this system track, in other words, data and information science track at the EE program. So those core data science faculty members, including myself, Professor Host Medicine, Professor Koo, Professor Satanam, and Professor Zhang. We all have a similar background in data science, signal processing, and statistics, but with the complementary skills. So I work in machine learning and artificial intelligence and optimization, applied to some image processing and computer vision problems. And Professor Host Medicine has a specialty in the information theory and signal processing. Professor Koo is doing a research in the machine learning and signal processing and power. And Professor Satyanam is doing a research in machine learning, statistics, and information theory. Professor Zhang is a specialist in the graph signal processing and the network science. Also, including myself, Professor Host Medicine and Professor Zhang is doing a research in big data. Okay. So the followings are the list of these undergraduate level data science related courses offered by UHMEE. So those include some programming courses, some fundamentals courses, and some advanced courses. So for example, in the programming courses, this objective-oriented programming is important, especially for students who want to build the real software products. Okay, and also in this among these fundamental courses, probability and statistics are the machine learning and linear algebras are the sort of the core courses. And in the advanced courses, we offer such courses like Introduction to Image Processing and Computer Vision and Introduction to the Optimization. So Introduction to the Image Processing and Computer Vision course now helps you to understand how to process images or patterns and how to analyze them. And Introduction to Optimization course now helps you to develop some fast algorithm for your software products. Okay. So some computer programming projects are also included in EE 345 lab and EE 416 lab. And yeah, so that's it. And the next slide now shows a list of the graduate level data science related courses offered by UHMEE. So we offer the bunch of the advanced fundamental courses, and also we offer some applications courses. So among these, in these advanced fundamental courses, we now see some examples such as computational image processing and computer vision course, linear and convex optimization course, applied random processes, and some machine learning courses as well. Okay. And also, we offer some computer programming projects in some of these courses, for example, EE 616. Okay. Right. So in this next few slides, I'm going to show you some of my research in blending this data science to the imaging science. So basically, my research spanned the field of data science and imaging science. So I've been developing the foundations of machine learning, artificial intelligence, and optimization, and some sampling theory, and apply these developed foundations to some applications in imaging, image processing, and computer visions. So for example, in the machine learning and AI, I developed this unsupervised and self-supervised learning framework that now can enable this deep learning only with the limited training data. And also I developed these fast AI system training algorithms, and also I did some research about how this big data is useful to improve the performance of your trained AI systems. Okay. My applications are pretty diverse. Those include medical imaging, computational photography, in short, the camera imaging, biomedical image computing, and autonomous driving. So I apply these developed theory to the modern medical imaging modalities, for example, X-ray CT, MRI, PET, and SPEC. And for this, my application research in the computational photography includes this live field imaging, which is basically a 3D camera, so that you now can capture the 3D information about the scene that is not really possible with the conventional or 2D camera. Okay? And for this biomedical image computing research, I developed this certain data science techniques to detect some abnormalities in the brain images. And I'm pursuing some research on the autonomous driving side as well. Okay. So in this next two slides, I'm going to show you some practical benefit if you apply this data science technique to the real world applications. The first application is this CT, which is computed tomography. Okay. So this CT machine is very powerful, and it can be applied to the diverse clinical applications. However, its biggest limitation is this radiation dose exposure. So if you're exposed to higher radiation dose, then you will have a higher risk of getting a cancer. And this is particularly important to youth populations. And also, in these COVID-19 situations, the CT has been reported to be the effective modern medical imaging machine to detect some abnormalities in the chest or the lung, especially caused by these coronaviruses. Okay, so in this COVID-19 situations, the CT has been reported to be the effective medical imaging machine to especially detect the abnormalities in the lung and chest caused by the coronaviruses. However, the one needs to get the repeated scans to see the progress of these abnormalities in their lung and chest. In such cases, radiation dose exposure, of course, increases. So the one wants to reduce the dose in the CT. However, if you reduce the dose in the CT, obtaining the clean and accurate images in CT is going to be extremely challenging. So this slide now shows shows a performance of the conventional method that is widely used in the industry, and some existing state-of-the-art AI method, and of this developed method by my groups. Okay, so the first two columns now shows the images reconstructed by or obtained by this conventional method and existing state-of-the-art AI method. Compared to these two methods for two different the scans that we acquire from the real scanner, the developed method by my group now can reconstruct the images with the higher accuracy and better generalization ability. You basically see the difference that the developed method now can give more clean and accurate images compared to the conventional and the existing state-of-the-art AI method. Okay. And the second example is this 3D camera. So if you have this 3D camera, we now can understand the depth of the scene. In other words, we now can differentiate how far the objects are from this camera. So this 3D camera was developed by the collaborative groups in optical imaging and sensor at my previous institution. And we use this one to estimate the depths. And if we apply the existing state-of-the-art method, then we see that many depths are not really accurately restored. But if you apply the method developed by my group, then we can see that the depth estimation is more accurate. We now can see the depths around the bowls and depths around the shoes, depths around the books, and depths around this jar more accurately compared to the existing state-of-the-art method. Okay. So, final remark. So if you wish to design, invent, and improve devices and algorithms that now enhance life for individual, and as well as solve some problems in the society, UHMEE is a great place for you. And you can find many electrical engineering related jobs in Hawaii as well. Thank you very much for your attention. I really hope that this preview presentation helps you to better understand the UHMEE program and its data science program. And for someone who's interested in my research, please visit my W website or my homepage. Thank you.